All right, hopefully that one wasn't too bad for you. So let's take a look at it together real quick. So first thing, again, with all these, what we need to do is find our reference angle. So when we have 135, that's in quadrant 2. So we're going to take 180 minus our 135, and that gets us 45. So really we're looking at sine of 45. But regardless, for sine, 135 is in that second quadrant, and sine is positive in the second quadrant. So that means that no matter what, if we're looking at 45 or 135, sine's positive because it's positive in the first and the second quadrants. So now we're looking at sine of 45. And we need to look at our 45, 90 triangle to help us out a little bit here. So remember, sine is going to be opposite over hypotenuse, so it's 1 over square root 2. Now we can't leave a radical on the denominator, so we've got to multiply this by square root 2 over square root 2 to get rid of that. And when we multiply square root 2 times square root 2, we're basically squaring it, so we're just going to cancel the square root. The numerator just becomes square root 2. The denominator is just 2. And that is our answer. So hopefully that's what you got. If not, it's okay. We'll get more practice here soon. So now we're going to take a little bit of a shift and take a look at how to find area of triangles using trig. So, sorry, I forgot about this problem first. So a little more real world example still, but this one here we have the swing arms of a ride pictured below are 89 feet long, and the height of the axis from which the arms swing is 99 feet. What is the total height of the ride at the peak of the arc? So what we're really looking at here is we're trying to find y, and then we want to add y to the 99 below it so we can find the height overall of this ride at its peak. So we have this triangle here, it's a right triangle. We have this angle going around, and we know that 200, since it's negative 200, it's halfway is 180, so 200 minus 180, all that's left here is 20 degrees. So for that 20, we need to look at sine, SOHCAHTOA, sine, cosine, tangent, SOHCAHTOA. And we have, from that angle, we have the opposite and the hypotenuse. Opposite and hypotenuse is together in sine, so that's what we're going to use. So we're doing sine of 20 degrees, and that's going to be equal to our y over the hypotenuse of 89. Multiply both sides by 89. So our y is equal to 89 sine of 20. Comes out to be about 30.44. And so our height is going to be that 30.44 plus the 99 we already know is the axis point. So when we add those up, we get our height of 129.44 feet. So now we're going to take a look at using trig to find area. And it's actually fairly simple. Just will depend on what you're given and what you, just what you're given, right? So no matter what, if you're given angle A and you have sides B and C, then you can use those three together. If you're given angle B and you have sides A and C, use those. If you're given angle C and sides A and B. So it's the same formula. It's just dependent on which pieces you're given to plug in. So for our one example of this here, we have our triangle, we have angle A, we have sides B and C, so those are what we're going to use. We don't have side A, we don't have any of the other angles, so we can't really do anything with that. So we have to use what's given to us. So our area is going to be 1/2 BC times sine of angle A. So you have everything to plug into this, and we're ready to go. Area is equal to 1/2. B is 6, little c is 3, and sine of 25. So we're ready to go ahead and start simplifying this down. 6 times 3, of course, is 18 times sine of 25. And then, of course, half of 18 is 9. So 9 times sine of 25 gets us our area, and when you plug that in the calculator, rounding to the nearest tenth, we get 3.8 square centimeters. So up next, we're going to take a look at some special laws of trigonometry that help us to be able to solve triangles that are not right triangles. So let's take a look. So the first one we're going to see is called the law of sines. And this one, of course, uses sine, and it can be used to solve any triangle. It doesn't have to be a right triangle anymore. I mean, you could use it for right triangles as well, but it's kind of redundant to use it for right triangles because we can use our regular trig functions for that. But any other triangle could be solved using these laws. And for now, we're going to look at the law of sines. Not every triangle can just be used or could just be solved using law of sines, but we'll see another one here that will round it out so we can for sure solve any triangle at all. So using the law of sines, we're going to solve this triangle, and before we do that, solving triangles just means we're finding everything that's missing. So we're missing one angle here and two sides, so we need to find all three of those pieces. And most of these, it'll be that way. You're going to be missing 3 parts. You are given 3 parts, and use those 3 parts to find the other 3 parts. So in this one, we are missing angle A. Since we're only missing one angle, that third angle, we don't have to use any trig to find that, because we know that the sum of all the angles of a triangle add up to be 180. So A is just equal to 180 minus the sum of the other 2 angles, 153. So angle A is 180 minus 153. And of course that is 27. So we have angle A already. Go ahead and label that in there. 27. So now we have all 3 angles. We're ready to go ahead and start using that law of sines to find the missing sides. So let's find side C first. So for side C, we need to use sine of angle C, which is 100, over C, equal to, and of course we have angle B and we have side B. That's what we're going to use as our base to find these other pieces. So sine of angle B, which is 53, over side B, which is 9. So now to solve this, we're going to cross multiply. So we have C times sine of 53 equal to 9 times sine of 100. So now to get C completely by itself, we need to divide both sides by sine of 53. So at this point, we have C all by itself, and we just need to plug what's on the right side into the calculator. 9 times sine of 100 divided by, and that whole thing divided by sine of 53. And when we do that, we come out with what our side C is, and it says around the nearest tenth if necessary, so doing so gets us 11.1. We don't have units for the sides, so we'll just leave it as that. So now we need to find side A. We're going to do the exact same process. We're just going to switch out the C parts with the A parts. So sine of A, which we already found, is 27, over little a is equal to, the right side is going to stay the exact same because we have the parts for B already. We could technically use C as well, now that we know what little c is, but since the decimal, no one really used that, right? So we are going to do sine of 53 over 9 again. And now, same exact process. Cross multiply. So a times sine of 53 equal to 9 times sine of 27 now. I don't know what I'm doing with my writing there. Turn the 2 into a z for some reason. And then the same process, we're going to divide both sides by sine of 53. So really the only thing that's changing in our calculation is that we're doing the sine of 27 instead of the sine of 100. So depending on the calculator you're using, all you got to do is just go back to it and change the 100 to 27. So that's kind of nice. And when you do that, again, rounding to the nearest tenth, we end up getting 5.1 for A. So let's look at another example. So before we get to our next example, there's some situations where you can end up with a possibility of one solution, no solution, or two solutions even. There's only one case when you end up with two solutions, and that's down on the bottom left there, where A is between the height and of the triangle and the other side, the side opposite of the angle we don't know. So that can be a problem. It makes it so you have to do a lot more work because you have to find two different possible solutions to it. But we could also have just one solution, and there's three different options that can do that, depending on what that measure of angle A is, if it's acute or obtuse. And then, of course, there's two options that could be no solution, and that's, again, it just has to rely on these different things. If A is less than the height, there's no solution if angle A is acute. If angle A is acute and A is equal to H, there's one solution. If angle A is acute and A is between the height and the side opposite the angle that's mysterious to us, then we don't. Then there's two solutions. Sorry, and if A is greater than or equal to B, then there is just one solution. If angle A is right or obtuse, if A is less than or equal to B, then there's no solution. If side A is greater than B, then there is one solution. So we're going to see what we come up with throughout this here. So this first one, first we need to figure out how many solutions we have, if we have any at all. And if we have one or two, then we're going to find them. So with this one here, we know that Q is obtuse. And since Q is obtuse, we need to look at the sides that we're given. So the 8 and the 11. 11 is the side opposite of our obtuse angle, and that is greater than this other side we do have. So that means we do indeed have just one solution. If it was the other way around, then there's no way that could form a triangle, because the side opposite the obtuse angle in a triangle has to be the longest side. There can only be one obtuse angle in a triangle, right? So we got our one solution. We're ready to go. We can actually solve this triangle. So we need to find our other two angles and side P. And since we are missing angle N, that's going to be the first thing we want to find. We're missing angle P as well, but we don't have side P, so we can't find either one of those without having angle N first. So sine of angle N over side N is 8 equal to our stuff with Q. We do have everything for angle Q is 110, side Q is 11. So now we're ready to cross multiply. So 11 times sine of angle N is equal to 8 times sine of 110. And we need to divide both sides by 11. Now when you're finding the angles, we have an extra step to deal with. So if sine of angle N is equal to 8 sine of 110 over 11, and our extra step is that we now need to do the inverse sign to get N by itself. So N is equal to the inverse sign of that fraction. And when we plug that into the calculator, remember, you need to make sure your calculator is in degree mode too. If you're not getting these answers, then you should be in degree mode, not radians, and that's probably the problem. And when you plug that in, it says to round the degrees to the nearest degree, so that is going to be 43 degrees. So we've got N now. Now, of course, that is rounded, but we're not worried about the rounding stuff. We're just going to deal with it as we go. So now we have 2 out of 3 angles. We can find angle P. So angle P is going to be the 180 minus the sum of the other two angles. So 180 minus 153. So ironically, it's also 27, like angle A was earlier. And now that we have all three sides, we have all three angles, we have 2 out of 3 sides. We need to find our third side, side P. So, sine of side P over, sine of angle P. We have that now, it's 27. Over side P equal to, we're going to use Q again, just in case, because we know everything else is rounded. We don't want to use too much rounded off stuff. So, sine of Q, 110, over side Q, 11, ready to cross multiply. So P times sine of 110 is equal to 11 times sine of 27, and dividing both sides by sine of 110. So little p is equal to, again, this one says, since it's a side, wants us to round to the nearest tenth, we get 5.3. So that's a good example. When we had one solution, we were good to go on that one, right? Let's check out this next one. Same idea, different triangle. So we need to figure out if we can even make this triangle happen. So E is acute, the angle we do have. So now we need to look at the sides that we do have. So 5 is less than 9, right? Which means we need to find that height as well. We need to compare the height in there. So our height is part of this right triangle here, right? On the left, if we're just we ignore the stuff off to the right of the height. We have a right triangle off to the left. And from the 52, we have our opposite and the hypotenuse. So for that right triangle, sine, because it's opposite and hypotenuse, so katoa, right? Sine uses opposite over hypotenuse. So sine of 52 is equal to the height over 9. We multiply by 9 on both sides. And our height is just 9 times sine of 52, which comes out to be about 7.1. Now, back on that graphic we saw earlier, we want to compare A and H. And A, is it equal to, less than, or greater than H? And our A here is 5. It is less than our height of 7.1, which means we have no solution. This 5 isn't going to be long enough to reach down here at all. It's never going to cross that side, so it's never going to make a triangle. So if we were to swing this left or right, it's never going to hit this side down here. That angle's too big. It's ironic that it's too big, right? Because it's a 52-degree angle, but it's still too big for a 5-degree or 5-unit side to be across from it. With a side that's 9. We could also shrink that 9 down. That would work too, but it's no good. Let's keep it moving. All right, so in this case, again, got to look at what we have here. So X is acute. Our sides are doing a very similar thing to what they did the last time. 9 is less than 15. So now we need to take a look at the height as well. So finding our height is the same process we did before with different numbers. So it means we're going to end up multiplying the hypotenuse times sine of our angle. Height is just 15 times sine of 28, which comes out to be about 7.04. Well, our height now is less than both of the two sides, right? That's good. So our height is less than A, which is less than B. In other words, 7.04 is less than 9, which is less than 15. So that's good. That means that this is going to swing. It's going to hit once, but it's going to also swing and hit twice down here. So it's going to hit 2 times. So we have 2 solutions. And we need to figure out the possible sides and angles for both. There's a lot of work to do with this one. So our first solution, solution 1. We're going to do sine of 28, because that's the angle we do have. And that's going to be over 9, because that's the sine opposite of the 28, equal to, the angle it's missing is z, because the triangle is XYZ. So sine of z over 15. So I'm going to skip some steps here, but when we cross multiply and then divide, we end up with sine of z equal to a fraction. We need to do the inverse sign. So we end up z equal to inverse sine of 15 sine of 28 over 9. And that gives us angle z equal to 51 degrees. So now we have angle z, we have angle x already. So y is going to be 180 minus the sum of those two, 28 and 51, which is 180 minus 79, or y, capital Y, is equal to 101. And now the last thing we need to do is find side y. So sine of 28 over 9 again, equal to sine of 101 over side y. And again, I'm going to skip some steps here, try to save some space for the rest of what we need to do. Y ends up being equal to 9 times sine of 101 divided by sine of 28, which is, rounded to the nearest tenth, 18.9. Now, we have one solution. We need to take a look at solution 2. You might be wondering, well, how do we do this, right? What do we need to even do to start this? Well, the process of finding what z was gave us a decimal, basically, that we did the sine inverse of, right? But remember, sine is positive in both the first and second quadrants, which means there's also a sine, or an angle, that gives us the same decimal when you do sine of it that's in the second quadrant. So sine inverse of the decimal that we had, that 15 sine of 28 over 9, of 0.7825, that's the decimal. In the second quadrant, basically means we just need to take 180 and subtract the 51 we used for angle z before, or we got for angle z before, and that gives us 129. So that's our new angle z. Think of it as the 51 is our reference angle for the other sine in the second quadrant. So now we have z, we can find our angle y the same way. 180 minus 129 plus 28, which is going to be 180 minus 157. So angle Y is 23. And now that I have that, we can go ahead and use our law of sines to find side Y in this case. So sine of 23 over little y equal to that sine of 28 over 9. Again, I'm going to skip some steps here, but y is equal to 9 times sine of 23 over sine of 28. So little y comes out to be 7.5. So there's our two solutions in this situation with this particular possible triangle. Two possible triangles. So let's keep it moving. Next up, you got a real world example here. So a baseball is hit between second and third bases and is caught at point B as shown in the figure. How far away from second base was the ball caught? So that means we're looking for, if that's side B, doesn't really matter which side is A or C. Let me use a different color so it's a little bit easier to see. So we're looking for side A. That's what we're really looking for. We're given side B. So all we really need to do is use the law of sines one time because, well, we know 2 out of 3 of our angles, right? So we can find angle B easy. It's just 180 minus 41 plus 58. Or 180 minus 99, which is 101. Sorry, 81. 81 is angle B. Now we need to use that with our side B, angle A, to find side A. So sine of angle B, we just got, is 81, over side B, which is 90, equal to sine of angle A, which is 41, over side A. I'm going to cross multiply. And again, I'm going to skip some steps here, save some time. But A comes out to be equal to 90 sine of 41 over sine of 81, which comes out to be rounded to the nearest tenth, let's say, is 59.8 feet. That's how far away the ball was caught from second base. So now we're going to take a look at these other law, the law of cosines. So together, the law of sines and the law of cosines is going to help you solve every type of triangle possible. So all this one is one little side squared equal to the sum of the squares of the other two sides minus 2 times the product of the other two sides times cosine of the angle opposite the side we said equal to. Yeah. So let's take a look at some examples of this. So we have this one here, and what we want to do is we are given angle C but not side C. So we're going to use that to help us find side C. And once we have side C, then we can find any of the other angles using the law of sines, and then find the other angle, the last remaining angle, using the fact that all the angles add up to be 180, the triangle angle sum theorem. So little c squared is going to be equal to, so the base form of this is one side squared is equal to the sum of the squares of the other sides, so a squared plus b squared minus 2 times a and b times cosine of angle C. So we have angle C, we have side A and B, we just need to find side C. So C squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 times cosine of angle C, which in this case is the 73. So plugging these in, or simplifying this down before we plug it into the calculator, 7 squared is 49, 10 squared is 100, 2 times 7 is 14, 14 times 10 is 140, times cosine of 73. So we can simplify a little bit further, adding up our 49 and 100 to be 149 minus 140 times cosine of 73. And at this point, really, the only thing we can do is just square root both sides. So C is going to be equal to the square root of all that. 149 minus 140 times cosine of 73. And we're ready to go ahead and just plug this in the calculator and get our answer for C. It doesn't say where to round, but we're just going to keep going with the same thing we've been doing, where we round to the nearest 10th. So that's going to be 10.4 for C. So now we have little c, we need to find either angle A or angle B, doesn't matter which one we start with. We're going to have to use C, unfortunately, to find this. So we do have to hope that we got that right. If we didn't get that right, we're going to start getting everything else wrong. And that's the one downside of using the law of cosines to start with these. But we couldn't start with anything else, so that's kind of what we had to do. So we're going to find angle B first. So sine of B, side B is 10, equal to sine of our 73 over the 10.4 we just got for side C. So solving this like usual, cross multiplying, we get 10.4 sine of B equal to 10 times sine of 73, and we divide both sides by 10.4. And now we need to do inverse sine of B, or inverse sine to get B by itself. So the inverse sine of this fraction, 10 sine of 73 over 10.4. And we get our B, again, rounding to the whole degree for degrees, it's going to be about 67 degrees. And now the only thing we are missing is angle A. And angle A is just equal to 180 minus the sum of 63 plus 73. Those two add up to be 140. So it's 180 minus 140. So angle A is about 40 degrees. It's not exact because we didn't use exact numbers here, but that's what it is. So moving on, our next one. Sorry for that there. Trying to do some things during class here, so it's a little bit more complicated to make videos whenever I have other Zooms and things happening. So this one here, we have all three sides, and we need to find all three angles. So we're going to start with law of cosines. We're going to work backwards with this one to find one of the angles. It doesn't matter which one we start with. We'll start with A, just to go in alpha order. Why not? Then we'll find B, and then we'll find C. So all the angles. So again, we're going to use the same setup we did before, where C squared is equal to A squared plus B squared minus 2 AB times cosine of angle C. So side C we do have this time. That's 12. We have A squared, or sorry, with A, which is 9 squared, plus B is 7 squared, minus 2 times 9 times 7 times cosine of angle C. So we got to work backwards. We're going to simplify where we can here first. So 144 for the 12 squared. 9 squared is 81. 7 squared is 49. Negative 2 times a positive 9 is negative 18. And then 18 times 7 is 168. All that times cosine of C. So we need to combine things together we can. I know I earlier said I was going to find angle A first. That's my bad on that. I didn't do that, did I? We're finding C first. That's okay. So we got 81 plus 49, that's 130. Minus our 168 cosine of angle C. So we're going to subtract 130 from both sides. Which is going to give us 14 equal to a negative 168 cosine of C. All right, so then we're going to divide by a negative 168 on both sides. And then we're going to do our inverse cosine to get C by itself of this fraction. We're going to leave it as the fraction. All right, so I just realized that I made a mistake because 168 there, I wrote down my work using where we found A first, and that I didn't do things right. Anyway, that 2 times 9 times 7 is 126, not 168. So we're not dividing by 168 here. Bring this up a little bit here, sorry. My bad. Using my notes that I did things differently. So, negative 126 cosine of C. Now we're going to divide by a negative 126. Everything else was okay though. So we're going to do our inverse cosine now of our fraction. And that does come out with our correct answer of about 96 degrees for C. So now we need to find angle B or A, doesn't matter which one's first. So not cosine, we're using law of sines now, sine of our 96 we just got over side C, which was 12, equal to sine of, again, it doesn't matter which one we find first, let's do A, why not, over side A is 9. We're going to cross multiply. So we get 12 sine of A equal to 9 sine of 96. We divide both sides by 12. And we then need to do our inverse sine. So we have A is equal to the inverse sine of 9 sine of 96 over 12. We're ready to get A. And that comes out to be about 48. And now we need to find B. And again, B is just going to be the 180 minus the sum of 48 and 96. Now, the one problem I have with rounding to the nearest degree with this is that it's not going to come out perfect. If we were to not round these, we would end up really good off, but it's not. So B is not exactly going to be what really B is. It's going to be like 1 degree off, but that's okay. Rounding does that. So 48 plus 96 is 144. And our B comes out to be about 36 degrees. So now these do add up to be 180, but only because of the way we did this. If we didn't round, we would have had some decimals that would add up to be 180 instead. So it just kind of depends on how you do things. But yeah. So we got one more to look at. And before we get there, we need to know when to use what. So that's what this is telling us. So solving oblique triangles, so that means just any kind of triangle. If you have two angles and any sides, then you start with the law of sines. If you have two sides and an angle opposite of one of them, start with the law of sines. If you're given two sides and their included angle, start with law of cosines, and then you'll use law of sines after that. And if you're given three sides, start with law of cosines, and then use law of sines after that again, just like before. But if you start with law of sines, there will be no need to use law of cosines. So there's that advantage for those first two. They're a little bit simpler. So our last problem. Two pilots in a stationary airplane look 38 degrees to the left of their runway and see a bus 75 feet away. They look 28 degrees to the right of their runway and see a truck 110 feet away. How far apart are the bus and the truck? So let's draw a picture. I'm not the artist that I wish I could be, but that was a pretty bad airplane. Anyway, here's my even just about as bad airplane. So they're coming down the runway. They look off to the left. (28 degrees). And they see a bus. And it is 75 feet away. They look off 38 feet. Not 38 feet, 38 degrees to the right. 110 feet away. And they see a truck. We want to know how far apart they are. So we're really looking for one side length on here. We have 2 out of 3 sides. We have one angle. So we can really use either law of cosines, probably going to be our advantage because we don't have 2 angles given to us, so law of sines wouldn't help us. So law of cosines is the best bet here. So our distance between those is squared equal to the 75 feet squared plus 110 squared minus 2 times 75 times 110 times cosine of the combination of our angles. So we got to add those up, 28 and 38. Because those are from the straightaway down the runway angle. So squaring all this stuff, or actually we're just going to square root. We're not going to square all this stuff individually because that's a lot of large numbers there. So 75 squared plus 110 squared minus 2 times 75 times 110 times cosine of, when you add those up, it's 66. And now at this point, we're just ready to go ahead and plug that in the calculator. We get our distance, comes out to be about 104. It doesn't say where to round, so we'll just round to the nearest tenth, 0.9 feet. So 104.9 feet. All right, up next, you got your exit ticket. So make sure you do that, and I'll see you guys next time.